as it is less likely to. Damn, okay. That's actually really good looking. Today we're going to be putting two of the arguably most popular agentic coding tools in a head-to-head battle in a couple of different tests to see how well they can actually perform tasks of varying complexity. Of course, first and foremost, in the left-hand pane here, we have, I'm not going to do that. Subscribe. So we have first and foremost in the left-hand pane, Codex by OpenAI, which has been recently updated to use a variation of GPT-5. In the right-hand pane here, we have Claude Code, which is quite well known and rather popular in terms of agentic coding. Now, really, I can go ahead and basically just close both of these browser tabs, as for today's testing setup, we are going to be using both of these tools through the command line. So in the left here, we have Codex, and on the right, we have Claude Code. Now, I don't want to spend a lot of time on the preamble because I would like to just get into the testing. I do want to mention here that there will be two tests we do. The first is going to be something kind of fun and lightweight that neither of these will have any real difficulty with, but it will be a good measure of some of their aesthetic and design choice capabilities, so to speak. Next up, we're going to do something that truthfully, I don't believe either of these will actually be able to successfully complete, but I want to really push them in some more like low level tasks in terms of like actually doing like bare metal programming and things that may not necessarily be the common use case for either of these tools. So with that, let's go ahead now and just jump in and take a look at our testing setup in either of these, and we'll get started. In terms of the way these are actually being used right now, both of these are just through the actual like web interface login. So essentially I logged in with Codex just by having it go to some ChatGPT link, and with Claude Code it just went to some like Claude.ai link. So that is just kind of maybe a question that folks would have, is how specifically I'm calling these, and that is just that methodology. Beyond that, in terms of the testing, I would like to keep this relatively fair, and again, it's not going to be exactly one-to-one, being that GPT-5-Codex did just come out like yesterday. But I think for the first test, because it is going to be the browser operating system, which a lot of folks were upset I neglected to include in my Codex testing video, so I apologize, but I'm making up for it now, hopefully. So I think for the first test, which is that, being that it's not super difficult, I will use GPT-5 Codex with Medium, which is just kind of the default of what was selected automatically, and because I am using that, I will opt to just use Sonnet 4 here, which is the default recommended for Claude Code. Obviously, usage limits are something that unfortunately seemingly go hand in hand when Anthropic is brought up, especially with agentic coding, things like this. So I don't want to kind of risk blowing through my usage limit with Opus 4.1, and I will opt to use Opus 4.1 and Codex High for the follow-up task that we do here, which will be significantly more difficult. So with that, I'm just going to leave both of these models the way they are right here, and we'll basically be able to just hop in and start our prompt. Now, I would like to make note that there are a lot of passionately charged individuals who find this area of exploration to be interesting, so it is very likely that I'm going to be using these in a manner that some folks would be like, well, you should have done this, or you should have done this. I just would like to test these at a very basic level, using them through the command line, giving them the same prompt, and basically just looking at the final result. So please keep in mind, this is not like a scientific test. This is just kind of like getting a feel for something in a real world scenario. Now with that, let's just go ahead and paste this in to both of these and press enter and press enter. And basically a lot of this will probably just be like a time-lapsing, but I'll keep an eye on them and monitor them to see if we see anything funny or interesting. I will say, seeing that token iteration there thing did just cause some level of anxiety. So yeah, all right, well, let's see what happens. So Claude has gone ahead and asked me if I want to go ahead and create index.html. Yes, and please allow yourself to do as you please from within this folder. So hopefully it will just autonomously go ahead now and continue to make files as it sees necessary. And we can see here that Codex is just kind of doing a lot of thinking and planning and things like that. And then Claude is just making subdirectories for the JavaScript scripts that it's going to be creating here. And ChatGPT is starting file creation in HTML structure. All right, I suppose there would be kind of some feedback based off of the aesthetic things we view in using these in the terminal. I don't know specifically. I would go out on a limb and guess that most folks are going to be using this with something like root code, or at least like as a VS Code extension. I don't know how many people would use these strictly through the command line, if you're not hardcore like me. Now, Claude has opted to be kind of like self-important here, naming this Claude OS. So we'll have to see if ChatGPT keeps that same level of off-putting confidence in oneself by naming the operating system after itself. Regardless, we will just kind of see what happens here. Now, it does seem like Codex is getting ready to actually have completed its result, just based on the fact that the plan here is now fully checkmarked off, or its to-do list does seem like it has been finished, and it is just preparing to reference code lines. Okay, so it is just going over and checking over its code now, but it does seem like, if I had to take a wild guess here, Codex is going to finish first. Okay, so this called it Nova OS, which is good. Not as nice as Claude OS, but, and then we just have like a little bit of a summary of what was done here. After a significantly longer time than it took for Codex to generate its result, Claude has also now done the same. Now, something I noticed just in kind of babysitting this, or not babysitting, but just watching it as it was actually generating things, it does seem that this is going to be a far more intricate result, and I believe that will be supported as well by basically, if we click on Claude OS right here and then go into the JS folder, we can see that there are actually specific scripts for every single one of the apps that it has created here for this browser OS, or Claude OS as it has dubbed it, as opposed to the GPT one, which just basically spit out 3 scripts. So that is definitely something interesting, and both of them have basically just said go ahead and open index.html in your browser and enjoy. So we will now do that. Let's first take a look at the Codex result right here, and we will just use Chrome for this as it is less likely to. Damn, okay, that's actually really good looking. I love the, this is like a software as a service startup, purple, blue, gradient-ish scheme. This is really nice. Focus sessions. I don't know what that means, but it sounds like some lingo from somewhere that I would just not want to have any involvement with whatsoever. Okay, it did say San Francisco weather, 72 degrees. I wonder if that is actually correct. Let's try it. Let's first and foremost, let's fact check this forecast. All right. Okay, so that's just not right. All right, that's all right. You know, it was still somewhat immersive. All right, now playing interesting. So is this actually properly iterating? It is not. That all right, but still, again, all right, sorry, it takes me a second to sometimes gather my thoughts when I see such beauty. So, all right, that doesn't do anything. Search. But it does look really good from a front end perspective. This is quite aesthetically pleasing. Okay, none of these are actually doing anything. Something I'm noticing here that is really weird, because like very, very small and less capable models consistently do this. There is no clock. All right, let's just click on. So unfortunately, none of these actually do anything. This is a very good looking result, but nothing at all actually functions. And right click is something I sometimes forget to check, but it's a good thing to check to see if they actually implement any right click like logic. So, okay, overall, this is very attractive, but it is basically just kind of like a skeleton framework with no real functionality behind it at all. But from an aesthetic standpoint, it is quite good looking. Now we will take a look at Claude OS, which, based on the level of complexity I'm seeing just from the scripts, it may be forgivable for it to have named this after itself. Oh, okay. Starting system, loading drivers. They do have a similar, interesting. I'm going to take a second to parse this, and then we'll go ahead and we'll see. All right, so I think the immediate thing that is noticeable here just between the two of these is this looks far more typical of what one would expect an actual operating system to look like. It has a taskbar, it has a start menu, it has the clock on the bottom right, as well as some fake battery, Wi-Fi, and sound metrics. So that is definitely, it's more like what one would expect. The clock is the correct time, and if I click on that, it actually does open this and show the time. I've never had one actually open a little like calendar, or not calendar, but just like I've never had anything actually give function to the clock and its result. So that is cool to see. Let's try a right click. Cool, very good. Very good, actually. Let's can we change our, oh yeah, we can. Okay, but we're gonna change this back. Okay, so that was the original. I kind of almost like this pinkish better. No, we'll go back to the original. I apologize. These notifications are really good looking, even though I kind of hate notifications that pop up like that on the screen, but that is good. Okay, we have a battery status. We have volume control that is actually like slidable, even though there's no volume. And then awesome. So it's actually showing fake Wi-Fi networks as well. Very cool. All right, let's now check our start bar. User, administrator, okay. And it gave me a nice little fake error message here when something is actually incapable of opening. That's good. Do these have hover effects? Okay, they do, which is good. Whoa. All right, so I'm not 100% sure what has occurred here. Yes. Did I? All right. Yeah, we'll just try that again. All right, so none of the apps are opening. Oh, all right, we got one. Can we resize this from the bottom corner? We cannot. Okay, aesthetically, it's okay. Let's do 65 times 6, 390. Okay, so our calculator is not entirely functional. So the calculator works, but none of the other apps actually open, which is quite perplexing and quite frustrating. I do have to wonder if it does have a specific script here for the calculator as well. Okay, so it does. So what exactly then is the issue? Now, I know it will likely be controversial to not go ahead and then give these a chance to subsequently fix the issues, which is basically like a lack of any applications opening whatsoever. However, and this is kind of more on the Anthropic side here, I do want to be mindful of my usage limits, being that the next test is going to be significantly more complicated. And truthfully, okay, say they fix the application issues, it'll be pretty and it'll look cool, but the core of it won't really show us anything beyond in terms of their actual like raw capabilities. So with that, I want to go into the next test now, which is going to be significantly more involved and complicated. And keeping in mind that Claude's result was definitely more intricate just in terms of the sheer level of code that it outputted. However, both of them kind of failed gracefully in the same exact way, which was just like actual app functionality. And truly, I've had better results from like way weaker models and non-agentic coding scenarios, so I'm not 100% sure what to make of that. Now for the next test, which is going to be more complex, I did just go ahead and kind of change the terminal color scheme, so maybe it will be a bit easier to read. I do apologize if there were any issues with the previous one, which I do like kind of better than the green, but I suppose, you know. So with this, I am now going to swap both of these over to the most complex and powerful model that they have available to us, which in this case is just going to be the high thinking capability here. So let me just do that one more time so we can kind of see. So we can see we're now on GPT-5 Codex High, which is the current one. And then if we go over to Claude Code here, we're going to select Claude Opus 4.1, where we can just basically press that. Now, this test is going to involve an actual physical device. So what we have right here is a Raspberry Pi Pico. It's like this little, just think of it as like a tiny little microcontroller or something of the sort. Now, this is essentially going to be having these models write in bare metal or basically with no abstraction layers at all to turn this into a small HID or something that basically can be connected to the computer that will be recognized as a keyboard. Beyond that, when a specific button that I will solder onto this is pressed, it will type hello into the computer. So this is very, very low level like work that I don't necessarily think these models are going to be able to pull off. However, I would be very happy to be proven wrong here. And basically from, like, we can see the prompt here. So write a bare metal C program for the Raspberry Pi Pico's RP2040 chip. The program must not use any functions from the Pico SDK. Implement a basic USB driver that makes the Pico enumerate as a human interface device keyboard. Configure the USB hardware by writing directly to its registers. The program should send a hello message by simulating the necessary keystrokes over USB when a button connected to GPIO pin 20 is pressed. So again, this is something that it's nice to write like fun scripts and things like that, like the Web OS, they're pretty. However, this is going to be a really extreme test of the capabilities of either one of these models, to the point where I would kind of bet against this being successfully completed by either one of these. But as I said, I would be quite pleased to be proven wrong. So with that, we're just going to go ahead here and press enter, and we're going to see, I'm just interested in seeing even like the initial like thought process here. So Claude has just gone ahead and generated something here just based on the fact that it is now prompting us to allow it to create and edit files, which we're going to be doing here. Okay, so just based off what we're seeing here, these are kind of things that would directly be accessing like the low level things on this device. So this will be kind of interesting to see if this does actually correctly work. And even Claude here said like, this is a complex task that requires implementing the USB stack from scratch. Okay, let's see. We can see Codex now is thinking. All right, and they both have kind of mentioned some of the same things right here, which you can see. And we're calling detailed PLL parameters and register layouts to craft a minimal bare metal USB keyboard example without SDK support. So basically what it means by right here is it's like basically thinking about the actual like clock cycles of the system and then like how to orchestrate them with like the memory registers and this probably like low level like things. But it's cool to see this. This is definitely a more out there test, but it's actually kind of fun to watch these, I suppose, depending on one's area of interest. And Codex did also mention the complexity is high. So they both have kind of said this is very difficult. Okay. So basically seems like Claude is almost finished, and I like this that it's actually showing us how to go ahead and at least partially the steps to get this onto the actual device here and then do it. So this is interesting, and that did actually finish relatively quickly. Now, this is not a very lengthy script, just in terms of like the raw number of lines of code that need to be generated here. This is just more intricate in terms of the like the ingredients that go into it, I suppose could be said. I will say, while Codex is finishing up right here, it's definitely doing a lot of intricate thinking here about potential points of failure and things of that sort. Things that I didn't necessarily see with Claude, but again, that is partially because Claude just was not giving me as much verbose information into its actual thought process here and things like that. But it seems like Claude, like this seems like a very confident result, I suppose could be said, just based on the fact that it spit it out relatively quickly, and it will be kind of interesting just to see here. And then Codex has also finished and just gone ahead and given us some next steps and things like that, and giving us even like a warning thing such as this program's untested, cross-check the register contents against the 2040 datasheet, and then blah blah blah, like a bunch of like complex things written. So just seeing this disclaimer and things like this here with the Codex result is something good to see. And the fact that I don't see that with Claude here in the actual instructions is, either a good thing, meaning that it's just so confident it knocked this right out, or a bad thing. So the next step now is to basically just actually go ahead and get this simple little program made or compiled and then transferred over to this little guy right here, which I will go ahead and do, and then we'll see if either of these actually correctly did this. So upon some further investigation, this is actually a surprising result and kind of the opposite of what I would have expected. If we look into the folder here for the Codex result, we see that there is one single file contained within here, which may be the correct technical implementation for this. However, this is missing kind of everything that would easily allow us to actually get this transferred over to the device right here. If we go back and look into the Claude folder right here, we're going to see a bunch of other things to the point where basically I'm in this folder right here in this terminal window. And okay, so we do see that there is an issue. However, being able to just do that is not something that would have worked from within the Codex folder. And I think basically the way to kind of put this simply perhaps is Claude gave us not only like the recipe, but it gave us the actual oven to cook it in as well, and the ability to actually cook those ingredients. GPT or Codex basically just gave us like the raw ingredients, but didn't really give us anything else. So the raw ingredients are what we had asked for, but at the same time, it should be implied or some level of understanding that we also need the actual recipe as well as the stove or oven in which to cook the actual ingredients. So I understand it may be a little convoluted explanation, but it's just interesting here to see that Claude actually did provide more of what would have been necessary here. So now we need to do some troubleshooting. So Claude's makefile has just a bunch of errors in it and unfortunately is not going to work as is. So I am going to do a second iterative test here, basically trying to get these to go ahead and actually produce a functional result, and they each need to be told different things here depending on what we actually need from them. So for Claude, I'm just going to say like basically, hey, your makefile's bunk, you need to fix it. So basically we're telling it to fix the makefile, and then for Codex we're actually going to need to ask it for everything else necessary to actually get this onto the device. Okay, so Claude said it fixed it and then also created a separate UF2 converter script. So this is quite interesting. Codex is actually searching the entire file system of the computer, and it's found the Pico SDK, which is partially like what's necessary for some of the things to actually get like programs and stuff onto this little device, and it's actually saying it's easier to just copy these things over. So this is neat to see that it actually went ahead and like autonomously looked for potentially what it needed and identified that it may be easier to just transfer these things over from the actual SDK. So I'm almost like, it's kind of scary that it did that, but it's also good from a functional and performance perspective. And Codex is actually just by itself running the make commands here, which we can see here Claude is telling us to do, because we had asked Claude to actually give us detailed instructions on compiling and transferring this. Again, I did not ask any of these to actually go ahead and autonomously do that, but Codex is going ahead and actually doing it itself. So there's some interesting behavior I'm seeing here from Codex, just based on the fact that it actually searched the system to find the SDK, which it was not prompted to do or anything like that. So like almost some scary levels of like agentic behavior, I guess would be the terminology for that. So they are now both correctly like done here, and I am just going to go ahead and ask the same exact thing for the instructions here to Codex as well, just so we can get an instruction set from either of these to compare, and then we will use that to actually go ahead and try either of these results on the physical device. So unfortunately, this has just become kind of a disaster. I may or may not be kind of regretting opting to do this test, but I do believe it will show us some interesting and maybe less commonly covered insight into how some of these are capable of functioning. So first and foremost, I'm going to ask Claude to actually make the file itself, which would just involve running these commands by itself, and then hopefully the errors that are actually coming when we run make, it will be able to see and then try to work around. And for Codex, basically what happens is Unfortunately, it's just not actually working to type anything in when we transfer that file over. So we will need to go ahead and have that try to identify and fix whatever issue is causing that. Again, I find it really interesting how Codex has actually gone ahead and just found the SDK and is like using that to search for things, which is very impressive. It's just very agentic behavior, I guess. And I'm not, I mean, that's like a, do you want to proceed? Yes, go ahead, do whatever you want. Approaching Opus usage limit. So this is obviously kind of one of the biggest downs. I'm paying, it's $100 a month, and I have not used Claude Code at all until filming this video. So the entirety of what we're doing here is the entirety of my Claude Code usage for indefinite amounts of time. Okay, so Claude did apparently create the file though, so that will be cool to see, and then we'll see if Codex can actually go ahead and fix whatever the issue is. And I think it is important to note, like the things we see on the screen right here, like the hex dumps and stuff like that, this is a really difficult task for these models, because if like one single thing is in the wrong spot or something, it's just not going to work. So this is very, think of like, use bowling as an analogy. So if you go bowling, you can put up the bumpers where basically you'll never go into the gutter. This is kind of the opposite of that, where if you don't get it exactly down, you can go and roll a gutter ball and things will not then work. So there is no real like assistance here for these models. They have to do it absolutely perfectly or else it will fail. And it's kind of like why I wanted to do like a bare metal testing, because there's no abstraction layer. It can't go ahead and use a library or something, even though Codex actually went ahead and kind of found the SDK for the Pico on the system and then tried using that to like teach itself or to better guide itself to do things, which was quite interesting. But okay, so apparently here we have this. So I'm going to try one final time, and we'll put this in the boot mode or whatever you want to call it. So let's go back to Claude here. Let's ensure that the actual file we need was just generated. Okay, and that was just a few seconds ago. So we should see the board immediately go away when that gets transferred in, and that's not happening. So unfortunately, that is a failure. So once more, I'll try it, but basically when we drag this in, we should see that just go away and disappear. But the fact that it isn't, and it's just kind of like sticking there, it's almost treating this as like a flash drive. So for all intents and purposes, this is basically just like transferring a file to a mass storage device, which is obviously not what we want to see. So unfortunately with that, I am sadly going to have to call this one and say that while they both demonstrated some rather impressive and very neat to observe capabilities, the core test here just did not work. And I had kind of hypothesized that this would probably be a little out of scope and difficult for these models, but these are things that the CEOs of these companies and things like that are talking about, how these are going to be replacing folks and they can already write like 70 or 90% of code, or will be able to soon. So when you hear people say things like that, you want to really put these things to the test hardcore. And these are things that folks do. I'm not someone who is a pro at doing any of this stuff. I mean, obviously this stuff is rather complicated. This is not just like, oh, let's do JavaScript and HTML and stuff like that. This is real like low level hardcore stuff. But I want to test these programs in very obscure and weird kind of use cases exactly like this. So even though we didn't necessarily get a successful result from either one of these on this run, I think, at least for myself personally, this really gave a lot of insight into some of the capabilities of these things, some of the ways they can function, even just having them like try to run make themselves so they could actually see the errors and then use those errors to go ahead and fix it is a very agentic coding thing. So I mean, I had a lot of fun testing these two. Obviously, the Web OS, it was pretty and fun and things like that. And the reason I didn't have them go ahead and try to fix the errors is from what we see right here, where we're already approaching the Opus usage limit and will likely hit it soon. And I knew that for the second test, we were going to need all of the usage allotment we could have. So with that, that is probably going to wrap up what is undoubtedly a somewhat frustrating video, but I hope it provided some insight into like a deep exploration of these tools. With that, if you have any questions, please feel free to leave them in the comments, and thanks for watching.